is about the work of Gilbert Fawcett-Peaker. In fact, it's going to take me more than one video to deal with the work of Gilbert Fawcett-Peaker. He's the most influential educational researcher that you've never heard of. And I'm going to start and focus upon his book, The Plowden Children, 4 years later. This book was published in 1971, and I read it shortly after it was published for the first time, and I was so impressed by it that I've carried the memory of this book with me through all these years. Let me first say about the Plowden Report that this is 4 years after. The Plowden Report was a landmark study in the UK looking at children and their primary schools, and it collected a huge amount of data about what the difference was between successful children and unsuccessful children in school. And Gilbert Peaker was the statistician who pioneered the statistical methods that were used on the Plowden Report. It's comparable to the Coleman Report in the United States. It's a major study, one of the first studies of the conditions of life of children and what made them successful in school or unsuccessful. In this book, published 4 years later, Peaker explains his approach to the statistical methods that he was using. And I carried that idea that he planted in my mind for decades. A few years ago, I came back to the book and looked again for the chapter on methodology that I was sure was there. And when I came to look for the chapter on methodology, I couldn't find anything. I read the book twice and I found nothing. Eventually, after deciding to go through the book word by word, I found this footnote on the bottom of page 1, carrying over to the bottom of page 2. In a footnote, Gilbert Peaker had described how he approached the statistical problems. And what it said was, the reader, unaccustomed to tables of this kind, may find the analogy of a yacht handicap helpful. At the end of the annual race round the Isle of Wight, the yachts have widely different elapsed times. They also have widely different handicap time. The spread of the handicap times is much less than the spread of the elapsed times, and would indeed be zero if the handicapping were perfectly successful and produced the handicapper's dream of a complete dead heat. If the mean square deviation of the handicap times is, say, 37% of that of the elapsed times, then the latter has been reduced by 63% by the application of the handicaps, and the 63% at the head of the left-hand column of Table A is to be understood in that sense. The evidence of the 1964 observations has been used to calculate the best handicapping rule, that is, the rule that will produce from the 1964 observations about each child a handicap in the shape of an adjustment to each 1968 achievement score, such that the spread of the adjusted 1968 achievement scores is less than the spread that would have been produced by any other rule based on the 1964 information. The purpose of the multiple regression analysis is to find this rule. In other words, to find the best weight to be attached to each item of the 1964 observations. Each weight is the same for all children, but the weights differ from item to item, in the same way that part of the yacht handicap might be 3 times the sail area plus twice the length overall, the 3 times and the twice being the same for all boats, but the areas and lengths different. So, for people who are unfamiliar with looking at statistical tables, Peaker suggests that it would be helpful to think of handicapping a yacht race. That's people like you and me who are not familiar with looking at tables will find this an easier thing to understand. Did it help? No, it didn't. It didn't help because you need to make an effort to link what you might possibly know about yacht races to what he's talking about. And it's not necessarily easy. What he says is that we should consider the round the island yacht race, and that yachts sailing round the Isle of Wight takes anything between 3 hours and 24 hours for boats to sail around the 50 miles round the Isle of Wight. Yachts going round the Isle of Wight in the yacht race will record an elapsed time, the time that it actually took them to get round the island. Some yachts will be near the average speed of boats that are sailing around the island. More will be close to the average. Some boats will take a very long time, some boats will take a very short time, but on average there'll be a distribution of the time that it actually took for them to sail around the island. What Pica says is that if we take the characteristics of the yachts, we can account for some of this difference in the time that they took to get round the island. For example, we know that long boats, large boats, travel faster than short boats. So big boats will tend to be over here where they've got small times. Small boats will tend to be over here where they've got larger times. If we corrected the times for the length of the boat, we might get a distribution that's more squeezed together. Suppose we multiplied by the time by the length of the boat. Long boats over here with small times would be moved this way. Small boats over here with large times would be moved that way, and we'd be left with a distribution that looks more like that, a narrower spread than we had in the first case. These boats here, long time, small boats will be moved back here. Large boats, small times, will be moved here towards the middle. And that if we take some measure of the spread of that distribution, if we take some measure of the variance, what Pica is going to say is that using the length of the boats, we have explained some of the difference in the raw times. The elapsed times, the solid line, the handicap times, the dotted line, and the handicap is the spread of the distribution of the handicap times is smaller than the spread of the distribution of the elapsed times. And Pica is going to say length of boat explains that much of the difference. Now we can do that again. We can take the handicap time that we've arranged for the length of the boat. We can say, well, we know that boats with tall masts go faster than boats with short masts. And so we can handicap again for a second time using the height of the mast to produce a second handicap time. And here in this case we've got explained more of the difference, and if we could do this, carry on using more and more characteristics, what Pica says is we will produce the handicapper's dream of a dead heat when all of the boats had the same handicap time. The theory being that if all of the boats have the same handicap time, the only thing that can make a difference is the skill of the skipper, the skill of the crew about how fast the boat goes. So there's several things to note here. Pica thinks that it's difference that needs to be explained. He thinks that by introducing variables into the calculations, we will take the average time, and if we take the average time, the handicap time will be the average elapsed time plus a constant times the length of the boat plus a constant times the height of the mast. And so on. This is a regression equation. We could go on adding in more and more characteristics of the yacht in order to, the yachts in order to explain why they're different, and to try and reduce the spread by introducing more and more characteristics of the boat. We'll get a better and better handicap time. Right, now then we come to the problem that Pica is trying to address. Suppose that the spread from the elapsed time to the handicap time, when we put the length in, suppose that the length explains 30% of the variance. And let's put the mast height in, and the mast height explains a further 20% of the variance. Between them then, they explain half the variance. Let's have a think about that. So between the two, the length of the boat and the height of the mast, they explain 50% of the variance. If you put the length of the boat in first, it explains 30%, and the mast height explains a further 20%. But if you put the mast height in first, the mast height explains 30%, and the length of the boat explains only 20%. Whichever one you put in first explains more. So the length of the boat alone explains 30%. Or the height of the mast alone explains 30%. Whichever one goes in first grabs this bit in the middle that is the joint explanation. And now Pica's got the problem. He wants to explain what order he's going to put the variables into his regression in order to work out what makes children successful in school or not. And he has some choices. And the first idea he has is that he could put in every variable on its own. We could put the number of siblings the child has, the job of the father, the job of the mother, what kind of primary school they went to, how many hours, whether they went to nursery school, how many hours they spent in school. All of these variables have been collected about these children. He could put them all in first into the regression to see which one has the biggest effect. But he tries it, and what happens is he discovers that the thing that is most closely related to the performance of children in schools, the thing that is best at handicapping their performance, is the qualifications of the teacher. Better qualified teacher you have, the better you perform in school. And so Pica's first thought is, that's it, that's the answer. Well qualified teachers mean that children perform well in school. And we'd all love to hear that answer. But he's not satisfied. And why is he not satisfied? Is because in the UK at that time, we had selective secondary schools. We were giving the children a test. The ones who performed best, we put into schools with the best teachers and the most concentrated curriculum, so that the children who were doing best in school got the best teachers. Now that can't be, that means that the better qualifications of the teacher can't explain the performance of the child. In fact, what Pica says is, things that happen earlier can affect things that happen later, but the things that happen later can't affect things that happen earlier. So what his conclusion he's coming to is that you need to put in the early experiences of the child first, their family background, their very early childhood, the nature of their family life, how many brothers and sisters, what their parents do for work. All of those things go in first, and then their primary school experience goes in after that. And what he discovers, not surprisingly, is that family background has a much bigger influence on a child's performance than their school. I mean, it's a kind of disappointing result for educators that the effect of schools is much less than the effect of the family background. And he tries to explain that as well by saying that, well, we control the quality of schools, but we don't control the quality of families. And so there aren't any really bad schools, although there might be really bad families. And so there's not so much variation in the schools as there is in the families, so families will explain more. I think he knows that's a bogus argument, really. But what we're looking at here is Pica has in his own mind an idea of how the world works. And the way he thinks that the world works is that early things can affect later things, but later things can't affect early things. And that means that he builds that expectation into his statistical analysis, and his statistical analysis confirms what he started out thinking in the first place. Now, I don't blame Pica for this. He's developing the techniques, he's a pioneer in the field, and he at least explains exactly what he does and what his problems are and what he's trying to solve. That's the reason that his thoughts stayed with me for decades after I'd read his book. And I don't think it's a characteristic only of statistical methods. I think it is in qualitative studies as well. If you go out to look at the world, the thing you choose to explain things first will be the thing that explains most. If you're expecting gender inequality to be the dominant feature, you can explain a lot of what goes on in the world in terms of gender inequality. It doesn't leave so much left over to be explained by other things. If, on the other hand, you think racism is the primary force in the world, you'll see racism everywhere, and that will explain most of what you see, and there'll be less to be explained by class or gender or whatever else it is that you may want to take into account. It's a natural feature of understanding the world is that the things that you focus on first explain most and leave less to be explained by other features of the world. You can't escape that, and what Pica is saying is you definitely can't escape it just by using statistical methods. I think there are some broader issues as well to take into account in terms of Pica's work, and I'll look at those in the second video that I'm devoting to his work.